Good morning, grade 12s. I hope you are doing well. Today is the 7th of May, and this is your IT lesson. And today we're going to start a new section. We're going to start looking at 2D arrays. So I'm just going to open up our screen here. There we go. Okay, so let's just backtrack. What is an array? An array is a list of things. So it can be fixed or it can have different elements to it. So in grade 12, you are going to start working with 2D arrays. We've got two arrays working together or working in parallel with each other. So a good example of this is, think of a movie theater, okay? So we all go to the movies and you buy tickets, and then it says row J, numbers 10 to 15, okay? So we have our rows, and then the columns would be the numbers, the seats in the cinema, okay? I'm going to enable the chat if anyone has any questions. And trying to get my cursor back. There we go. Okay, so imagine that you're writing a chess application. One of the main tasks of your application would be to record the position of the pieces after every move. Okay, so I don't know much about chess, but I can see here are columns A, B, C, D, E, F, G, and then I've got my rows here going 1, 2, 3, 4, up to 8. So if you wrote a chess game, you would have to be able to record what position. Let's go for something that I actually know. I think this is called a pawn. So that would be C2. So you would need to be able to record which position the different pieces were in. Okay. So your application would need to analyze each square of the chessboard after a move and record whether it contains a piece or not. Now, do you remember in grade 10, you had to design a game? And many of you use something like snakes and ladders, but what you did was you created, used a component or a shape for each block, and then you coded it that way. Now, can you just imagine if you had taken your game and used a 2D array instead, how much easier your coding would have been? Okay, so how are we going to do this? You could create 64 individual variables with each variable storing the name of the piece on it. This is pretty much what you did in grade 10 when you designed your game. However, with 64 variables, you would need to access each variable individually since you cannot use a loop to iterate through them. Okay, so trying to keep track of all 67 variables can get quite tricky. Furthermore, the computer would not understand the relationship between these squares. That is, that one square is above another one. So it's not just next to each other. There's above it, below it, to the left, to the right. Okay, making it very difficult to use in the rules of your game. A better solution would be to create 8 array variables, with each array containing the squares from one row. So for example, I would use row 1 and have the variables A, B, C, D, E, F, G, H. Okay. So this would have the benefit of your program understanding how all the squares in the rows are related. However, you would still need to individually access the 8 arrays, and your computer would still not understand the relationship between the different arrays. In fact, the best way to handle this data is to create a single two-dimensional array. A 2D array uses 2 indices. Okay, so indices is the plural for index. One for the row and one for your columns. This has a number of significant advantages. You can store the data or the elements using a single variable. You could scroll through the elements using a nested for loop. Okay, there's a hint there. The relationship between the elements, that is, which squares are next to which, is captured in the indices, making it possible to use these relationships in your code. Okay, so this is Unit 3.1 from the DBE textbook, 2D arrays. So since grade 11, all your examples of arrays have been one-dimensional arrays. So the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. The months in the year, how many days there are in a month. Okay, so a one-dimensional array stores an I number of elements of a specific type. These elements can be accessed using an index, usually I. For example, if you created an array to store the first 5 powers of 3, the values could be represented using a single row of elements. So for example, 3, 9, 27, 81, 243. So that is a single array. The third element in this array can be accessed using the array name and the index of the element in square brackets. So accessing an element in a 1D array. So I value assign A numbers 3. So let's quickly go back and see what number 3 was. 1, 2, 3. That would have been 27. In contrast, 2D arrays store two-dimensional data, which is represented using a grid with rows and columns. Each element in the 2D array has 2 indices, usually I and J. Think of fish and chips. Okay, so we've got I and J, with the first index giving you the row number. Now this is extremely important, okay? It's important that you do not mix up your row and your column. So the first index, I, is going to be my row number, and the second index is going to be my column number. Now, how am I going to remember this? Remember, row, then column. Okay. So this is somewhere in that quite a few times in the exams, the grade 12s have lost their marks simply because they first gave me the column and then the row, and then the data that comes out from that is incorrect. Okay, so then you end up losing marks. So keep saying to yourself, row call. Okay, so I and J is row, then column. Okay, so let's see. If you look at a 2D grid below, you will see that it is made up of 5 rows and 3 columns. The value of the first index indicates the number of the row. Okay, so we said here, the first index is the row. That means A numbers 1, J, where value of the first index is 1. Okay. This refers in the first row, while A numbers 2J refers to my second row. So this is first row, second row, third row, fourth row, fifth row. Okay. So then in contrast, the numbers in the second index indicates the column. So for example, A numbers I3 refers to the element in the third column. Okay. So that would be, for example, over here, or sorry, over there, I3. So if this was I1, that would be row 1, column 1, okay? Or I5, row 1, column, row 5, column 1. If I said row 3, column 3, it would be 27. Okay, so get in the habit of thinking row, then column, as if you're reading left and then from the top. Okay. And there we go. The numbers in the array were created by raising the index I, the row number, to the power of j, the column number. The table effectively shows how 15 integer values, do you see we're dealing with integers here? Remember, arrays, you have to use the same type in your array. You can't use different types. So it shows how the 15 integer values can be represented uniquely using the same identifier. So A numbers and the two indices surrounded by square brackets to distinguish between them. It shows 15 unique integer it shows 15 unique integer variables that can be accessed or can be assigned new values. Variables must be declared before they are used. Okay, so before we carry on looking at how to declare it, let's think of places I'm going to use a 2D array. So I want you to, in the chat, see if you can come up with an idea for, I've said there is the chess, okay, and I've said a movie theater. Where else could I use a 2D array? You can give me an answer. I'm going to give you about 5 seconds. Come on, I know you're all online there. A bingo game. Well done, Kateko. Okay, tell me, how would you use it in a bingo game? Haha, put you on the spot here. Okay, come, the rest of you, there are 6 of you or 5 of you online. I want an idea from each of you. Think of how you're going to use a 2D array in your pet. Remember, everything I'm teaching you is working towards your final pet. Okay, what about the parking area? Okay, in Kateko, let's see. Bingo usually revolves around placing a mark on a number you think it's going to be drawn. Excellent. So they will say, for example, B3, and then all the old ladies are going to get all excited with their markers and stamp their B if they've got a B3. Well done on that one. Okay. So there is, for example, a parking lot at the OR Tambo. So there are different floors. So that's almost actually like, I would say, a 3D array, because I've got my rows and my columns, and then there are different floors. So that's taking it a step further. Okay. Let's see where else there can be. We can even put our classes into arrays. Okay, so grade 12, and for each registered teacher, that could be an array. Okay, so think of all the different lists and things that you have to match, and how you can create a 2D array with that. Okay, great, let's carry on. Okay, how to declare a 2D array. So my syntax is going to be var a name, whatever, you can choose whatever it's going to be. So, but very importantly, I have to have the word array. Then 1 dot dot I, so 1 to I, okay, so to the last index of I, 1 dot dot j. Okay, so let's see how that would look in an actual code. I would have a numbers array 1 to 5, that's my row, and 1 to 3, that is my column, of type integer. So where I gives the number of rows in the array and j gives the number of columns, as can be seen from this declaration. 2D arrays have the same general limitations as 1D arrays, namely, so there are 2 limitations. So if you get asked in the exam give two, in the theory, give two limitations of a 2D array. You can say all the elements of the array must have the same type. So they must all be arrays or all strings or all chars, okay? And the array has a fixed size, okay? So make note of this point somewhere in your textbook or your book. Okay, so we are going to quickly take a look at this activity. I'm going to see if you can give me the answers to these, and I'm going to, let's see if I can, I'm going to stop sharing the screen for 2 seconds. I'll look at that. 10 rows, 10 columns of integers. Write the array for me. I just want to find the, I'll just open here on the side. Where did I put it? Okay, so I'm going to hide that slightly there. Okay, so who can tell me is the 10 rows and 10 columns going to be? How would I write that array? I'm going to go out of my presentation mode. Okay, so that I can type here. And my answer is going to be A numbers, array 1 to 10, comma 1 to 10. Okay, so there we go. A numbers, so 10 rows, 10 columns, and what is my type? Of integer. Okay, that one was easy. So what are we going to do for this one? 5 rows, and this time 4 columns of type string. Okay, very, very easy. A strings, so whatever you decide to call your variable is going to be 1 to 5 for my 5 rows. Okay, and 1 to 4 for my 4 columns. Okay, so do you see how easy this little activity is? I want you to complete that for homework. Here is a slightly more tricky one here, an array to model weeks and days in the month of May. Okay, so how many days are there in May? Let's quickly do the old-fashioned way. January, February, March, April, May. So all the knuckles have 31, and all the spaces between are 28 to 30. Okay, so January, February, March, April, May. There we go. And then I know there are 31 days, and I will have to work out the weeks and days in May as if you were creating. There's another 2D array, a calendar, something that you look at every single day when you look in your school diary. So there are so many different ways to create a 2D array in your PAT. Okay, let's carry on. Okay. Okay, all good, Kakiso? Okay, where we now? There we go. Okay, now accessing elements in a 2D array. Use the A number array above to reference the numbers given in the example. So the example here, it says assign 9 to I value. Okay, so the code would then be, because remember, the second number is like the square root of it. So to get to 9, my row will be 3, and the column is going to be 2. So 3 to the power of 2. Okay, here they say display the number 27. Now I can simply write a number. There's my array. 3, that's, 3, comma 3. And it's, remember, your indices must be in square brackets. And then because I can't display an integer, I'm going to change it to a string and display it using a show message. Determine the square root of 64. Okay, very easy. So to get to the square root of 4, it would be 4 to the power of 3, if I'm correctly, 4, 16, and then 16 times 4 is 64. Okay, and then I would simply add my square root on the outside. Remember your parenthesis. Okay. Increase the cost by 5%. Okay, so here, this actually, you could reverse this one. Say, if the people book their tickets a month or 2 months in advance, they could get a 5% discount. So cost equal, assign cost. So I've already probably set cost, declared, initiate my cost to 0. Then I have my array 5 dot 1 times to get my percentage 0.05. Okay, so that would be increase the cost by 5%. Okay, so when working with 2D arrays, again, I'm just going to keep repeating it because it's something that we do get confused. It is important to remember that the first index is the row, the second index is our column. Okay, great. So this is actually a very interesting section, this. And you'll be surprised to see how many different places you are going to start using your 2D arrays. Okay, so we're going to look at a few more examples and then how we would write that code. So assign the value 92 to row 3, column 3 of A numbers. So very easily to write that would be on the right side, I would have the value that I want to assign. And then this is going to be the position, A numbers, row 3, column 3. In this one, given 1 is less or equal to A, or no, greater, probably here, greater or equal to A, but less than equal to 5. So this is going to say assign the user input from EDT number to row A, column 1. Okay, so take whatever the user has entered, convert it to an integer, and then assign it to that position. So row A, column 1. Then we've got here 1 is greater or equal to B, less than and equal to 3. Assign this value to row 2. So simply, if you like here, this would be column 1, column 2. These are row 1, 2, 3, 4, 5. Okay, so 2B would be this column. Okay, if I was using this table to enter in. Okay, here, do you see that I can have more than a variety of conditions? So I've said here, 1 must be greater or equal to A or less or equal to 5, and it must be 1 is greater or equal to B and less than equal to 3. So assign the value of 10 div 3 to row A, column B. Okay, so there we have 10 div 3, and I'm going to write it to row A, column B. Okay, so you don't, my rows can be 1, 2, 3, 4, and my columns 1, 2, 3, 4, but try and make one letters and the other one numbers, just so it's easier for you to define. Okay. Okay, so activity 3.2, I'm going to read through it. You are going to finish it for homework. Look at the chessboard below. As you learned in the introduction of this chapter, the position of pieces on a chessboard can be represented using a 2D array of 8 rows and 8 columns. Okay. Based on this position, complete the following tasks. 3.2.1, declare an array of strings called a board. So there I've already told you what which variable and array to declare to represent my 8 by 8 squares. Okay. Assign the position of all the pieces to the correct element in array A board. Make sure to use different strings for white and black pieces. So let's quickly see here. W king would be the white king here. W bishop would be the white bishop. W pawn would be the white pawn. And B king would be the black king. And you would be able to work it out. You will have to go and read up a bit on the different chess pieces, their names. Okay. So I know there's a king and a queen, and I think there's a horse and a castle. I have to admit, I never actually played chess. I tried once or twice, but it wasn't something that took with me. Okay. So then 3.2.3, at the top right of the board, there are 2 yellow squares. So let's quickly go back and look at that. Okay. Okay, there's my yellow squares, except it's on the other side. These squares show that the white king moved from the first column to the second column in the previous move. How would you code this move using your array? Okay, so this is now coming back to your grade 10 project, seeing how you could have improved it. Okay, that's not a bad idea at this stage. Go and dig out that old project of yours and see if you can rewrite it with a 2D array. Okay, so it was in row 2, column 1, and the white king moved to row 2, column 2. So the name of the table, the pieces are given here in the table. And there we go. Okay, so I'm going to go off there. I'm going to end the recording. I want to say thank you very much. I'm going to stay online just to chat with you guys for a few seconds. And but that is the end of part 1 of 2D arrays.